Okay, here we go. Finding the surface area of triangular prisms. Let's do it. Okay. Finding the surface area. So the surface area is a lot of 2D shapes added up. We're looking at the surface of this 3D shape. So I reckon the best way to think about this is to draw a net first and just make sure we're covering every single side. So think, can you draw the net of a triangular prism? All right, so it's going to look like, just in general, actually that's a bit painful. Let's use these tools. Okay, so of a rectangular prism, of a triangular prism, sorry, we've got 3 rectangles that fold around some sort of shape. And I can see that this is a right angle triangle. It doesn't have to be perfect, but let's just get the main idea of how many surfaces there are and what types of surfaces are in this shape. All right, so we can see this shape folds out to 3 rectangles and 2 triangles. All right, now let's do it. So with total surface area, I like to write a formula first. Just write a general wordy formula that will tie everything together. So surface area, triangular prism, because sometimes this isn't given on the formula sheet, so it's just good to know how to derive it. It is going to be 2 times area triangle plus, well, we're going to have actually 3 rectangles, and it looks like they have all different dimensions. So I'm going to call one rectangle, rectangle 1, and this is going to be, let's call it, I can see a rectangle there. See how it's sloped? So I'm going to call that the slopey one. So let's just call it slope. And rectangle 2. Whatever you decide it to be. I'm going to call rectangle 2 that one against the wall, that rectangle that goes up against the vertical wall. Let's call that one wall. And then we've got that rectangle on the bottom. So we're just going to call that rectangle 3 and bottom, whatever you need to distinguish it as. And as we can see, there's 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got 5 shapes that we're going to be adding up. So this is our plan that we need to keep coming back to, and I'm going to find each of these separately. All right, let's do it. Area, triangle. Let's find them all down here. Area, triangle. Start with a formula. Formula for area of a triangle is half base times height. Or you might have seen it as base times height divided by 2, whichever you prefer. We'll just use half base times height here. Half times, and we're looking at this triangle shape. The base of that is 8. The height of that triangle, the perpendicular height, is 6. And let's just put that straight in our calculator. Half times 8 times 6, 24. So that is the area of one triangle. All right. And we know that we have 2 triangles. So I'm just going to say, therefore, area 2 tri equals 48 centimeters. I'm going to put a box around that because I know that I'm going to need to plug it into our planned formula up here. So tick that off. Now we're going to find the area of rectangle 1, area R1, the slopey one. So the slope one. And you can draw it out if you need to. I just realized there's no number here, which is great. So let's call this 30 centimeters. Now, area of this slopey one, if you drew it out, it would be a rectangle 10 by 30 centimeters. So area, general formula, length times width. Length is 30, width is 10. 30 times 10, take those zeros, 300. And area means squared, so then we do that. So let's just put a box around that. Now we've done that one. And I'm just going to say R2 equals length times width. And we define R2 as the wall rectangle. Now think about the dimensions of that wall rectangle. Okay, what will it be? It's going to be 30 is the long side. And what's the width of that wall rectangle? 6. Okay. 180. Put a box around it. Tick it off. It's just all about the process you use to find surface area. Just have a process. Rectangle 3 was the bottom rectangle and its dimensions are 8 by 30. I can just write that straight down. Once you've written the formula a few times, don't have to bother writing it all the time. So 8 3 is 24, 240. And there, we've found that. And now the last step is just to add all of these up. Okay. So let's do it. What am I doing? Surface area of a triangular prism. So then we can just write under here, therefore, total surface area is adding them all up. To add up all those box formulas. So the 2 times the area of the triangle, 48. R1, 300. R2, 180. R3, 240. Straight into the calculator. 300, 180, 240, 768. And then let's give some meaning to our answer. So we plugged in centimeters, so we must get out centimeters. It's a surface area. Area, think squared. And yeah, box around it just so your teacher can find your answer. So that's one type of triangular prism. There might be another one where they try to trick you a little bit by including this hypotenuse side, but I will show you. All right. So again, sometimes it helps to draw the net out. But let's actually just go straight for it this time. All right. So I know area. So total surface area, tri-prism. I know that there's 2 triangles. 2 times area tri. Plus, again, 3 different types of, 3 rectangles with different dimensions. So R1, R2, R3. Let's find them all separately. So this is our plan to keep coming back to. Now, let's have a look. What are we going to define R1 as? Which rectangle? I'm going to define it as the front rectangle. And then we've got that back rectangle. And then we have the bottom rectangle. You can always draw a little diagram of each of these 2D shapes if you need, which we might do actually. All right. So finding the first one, we're finding each of these separately and then ticking them off. All right. Area, triangle. General formula is half times base times height. Half times, what's the base of this triangle? It's 8. Times the height. Now you've got to choose between 3.3 or 7 here. With triangles, it has to be the perpendicular height. That means the height at right angles to each other. So the right angles to the base. You're going to choose that one that goes straight up and down. 0.5 times 8 times 3.3, 13.2. Now that's the area of one triangle. Now notice we've got this front triangle and we've got one at the back as well. And they're both of the same dimension, so we can just times that by 2. So area, therefore area, oh, that's a bit messy. Therefore, area of two triangles times it by 2. 13.2 times 2. 26.4. Put a box around it. Oops. And we can plug that straight in soon, so tick that off. Now let's find the area of the rectangle at the front. Area R1 equals. Look at those dimensions there. I can see that it's a rectangle of 6 by 12. Start with a formula always. So area is length times width, then 6 times 12. 6 12s is 72. And so R1, put a box around it, tick it off. Area R2. The back rectangle. Now what are its dimensions? That back rectangle, all right? We can actually draw it. Back rectangle looks like it has like a width of 7. And what is this side? Well, it must be like that side. So 12. So I can just go length times width, 7 times 12, 84 centimeters squared. So that's R2, box around it, tick it off. Area R3, which we define as the bottom rectangle, and we can see that that has a length of 8, or a width of 8 and a length of 12. So 8 times 12, 96. R3, box around it, tick it off. And now the final step is to actually use that planned formula we had and substitute all of our box things into there. TSA equals, well, we've already times that triangle by 2, so 26.4 plus 72 plus 84 plus 96. 26.4 plus 72. 96. 278.4. Give meaning to our answer at the end. Well, it's total surface area. Think squared. And we plugged in centimeters, so we should get out centimeters squared. And put a box around that so your teacher can find it. And we are done. So just remember, with surface area, start with this general wordy formula, adding up all the 2D shapes. And you may even want to draw a net at the beginning to check that you've got all the 2D shapes crossed off. And then you find all of these terms separately. And then remember to actually plug it into that formula you planned for in the beginning.